All right, you guys, we're back. Hopefully you did all right on lesson 10.4. This is going to be lesson 10.5, relationships of angles and circles, and lines and circles and angles. We'll just review this real quick. This is stuff we did previous to this. So if we're going to find the measure of arc B to C, this one, we've got to be able to find the arc of A to B first, and then we'll have to subtract it from 180 because this is a chord, a diameter. So if this is 30, we know that the arc it creates and it's inscribed, it has to be double, so that's 60. Well, the total is 180. So this one has to be 120. Because if they add up, they have to be a total of 180. Okay, well, that one's done. All right, let's go find this one. All right, we've got 77. We want to find that measure of angle P. Well, to do that, we've got to find arc R to Q. So I know that 360 is the total, so I'm just going to take 360, and I'm going to subtract 77, and I'm going to subtract 135. And that gives me 148. Once I have 148, because the total of that is 360, once I have 148, I'll cut that in half. And that'll be 74. Okay, and our last one over here, we want to find the measure of arc E to H. E to H is this one. Well, we have angle, E to H, yeah. We have arc, or angle 42 right here that creates it. So angle 42 is this one. It's creating this arc. We know it's inscribed, therefore it should be double. So 42 times 2 is going to be 84. Make that a little better for you. And 84 would be that arc that we're looking for there. They threw the 50 on there, not to confuse you, just to see if you really understood which numbers were going to help you find your answer on that one. This one's a review from a while back. They want to know how many lines of symmetry there are on these shapes. Lines of symmetry are if you can put a line through it and fold the shape over and have it land on itself, so this one would only have one. This one would have one there and one there, so two. And this one would have 1, 2, 3, 4. So those are all the lines of symmetry, okay? All right, here's the name of the lesson, angle relationships in circles. All right, so if I have a tangent and it intersects a chord, this is the theorem, this is a law. So if I have a tangent here, and it intersects chord AB, then it's going to create an angle. Well, that angle would be between angle 1 and angle 2 would be 180 degrees. Well, if that makes sense, then think about this for a second. If that's 180 from angle 1 and angle 2, then all of this is 360, so each one of them should be half of each other. So the angle 2 will be exactly half of the arc that it creates. Okay? And then angle 1 would be exactly half of the arc that it creates, because we have half of 360 with the angles. So that's how it works. Okay? So remember that picture. All right, so here they have this, and they want us to find the measure of the red arc or the red angle. So here's the red angle, and they gave us this arc, and it's in blue, and this arc goes from here to here. And so we know that's 130, so our angle should be half of it. So 130 divided 2 should be 65. So 65 is the measure of angle 1. Okay? Over here, we want us to find the arc of KJL. So this entire arc here. Well, we know that the angle is 125, so it should be double the amount, because they gave us the angle, so we're going to double it. We're going to times it by 2 to get the arc. So it would be 125 times 2 will give us 100 or 250, sorry. 250, so the measure of arc KJL, remember, if you have 3 letters, you're going the longest distance to it, 250. By the way, that would be a major arc, if you remember back to the major, minor semicircles. Okay, this one right here would be a minor arc because it's less than 180. Anyway, okay, let's jump into some of these now. Do some more. It says line M is a tangent in the circle. So this is a tangent, 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 and they are all intersecting a chord. And so it's the same type of problem we were just doing. So we're just reviewing some more. So if this is the arc, here being created, 210, our angle will be half of that. So 210 cut in half. It should be 105. This one, they want us to find the measure of arc, RST. So follow the 3 letters, you guys. R, S to T, that's the one they want. And this tangent is hitting this chord and creating that angle. So this angle will be double to be the arc. So we'll take 98 times by 2. 98 times 2 is 196. Got it? And then this one, they want us to find arc X to Y. Now remember, an arc that is 2 letters is always the shortest distance there, because some kids will always go, well, is it this way or is it this way? Well, it's always the shortest distance there with 2 letters. If it's ever 3 letters, then you follow the letters. So it's this, and they gave us the angle, so we will double it to get the arc. So 80 times 2. It's going to be 160. And that's it. That's how you'll do those. Okay? All right, we're going to go into another little rule. So pay attention to this one. Intersecting lines and circles. Intersecting lines and non-parallel lines that are not parallel will cross. Anytime 2 lines that are not parallel cross, they can cross in 3 places on a circle. They can either cross on the circle, they could cross in the circle, or they could cross outside the circle. Okay, now we're going to discuss some things. I want to review with you this. This one would be creating an inscribed angle. This one, don't mix this one up with, like, if 2 lines and we had a circle and 2 lines crossed on the center. That's not this one. Is that clear? They're not crossing on the center. Those angles are not central angles. They're trying to make sure that you understand. I'm trying to make sure that you understand that that would not be a central angle. Okay? And then this one crossing outside actually creates 2 little arcs. It's a better picture like this. And you can see that there's an arc there, there's an arc here. So 2 different arcs are being created. There's one here, and there's a larger arc being created here. We're going to need to understand that to be able to find that angle. Same with these, and same with these. We're going to talk about these 2 specifically. We already know quite a bit about this one. This is the inscribed one. Remember, that angle will be this angle will be half as big as this arc. If this arc was here, this angle would be cut in half. Okay? All right, so let's now talk about some of the rules. Here's the rules. So this is the one where they're crossing inside. Okay? The 2 angles create 180 degrees. Okay? For sure. But the angle for angle 1 will always be, if I take the arcs that are created from angle 1, they're vertical angles. Angle 1 will always be half of arc DC and arc AB, the ones that are vertical from it. So remember that. We'll add up those 2 arcs and cut it in half to get that angle. In contrast, angle 2 would be this arc plus that arc cut in half. Those are the vertical ones from it. Okay? So we'll deal with ones where 2 lines cross, but they don't cross in the center. Is that clear? Okay. Now here is a picture of angles outside the circle. Now there's three different things, but it's pretty simple. I'm going to break it down for you pretty simple. Okay? The blue one is always, the blue arc is always the smaller. Okay? So if we ever have a chord, here's a chord and a tangent, or if we have two tangents, or if we have two secants or chords that create an angle outside the circle. So when they create an angle outside the circle, just watch. It's simple. The angle that is made will always be the big arc, subtract the small arc, cut in half. The big arc, subtract the small arc, cut in half. The big arc minus the small arc, cut in half. It's always that way. Okay? So it's the big arc, subtract the small arc, cut in half. Hopefully you'll remember that, and we'll try to go through it as easy as possible, all right? So let's remember some things here. All right, so we've got two lines that intersect in the circle. That is not the center. Make sure that you understand that that is not the center. So the rule was, if they are vertical from it, so they're vertical from it, straight across. So this would be the same as that, and then these are the arcs that make it. So watch, we add them together. So we're gonna say x equals 130 plus 156, all cut in half. That's basically what it is, okay? So we're gonna go 130 plus 156 divided by 2, 143. So that's how you would find that angle. Okay? They're vertical from it, so make sure you understand that. Okay? If x was over here, then we would have had to have subtracted that from 180 to find out what that. Anyway, you just got to make sure that you understand it's the right spot. Okay, this is an angle outside. So we've got a big arc and a small arc. Just remember, x will equal the big one, 178, minus the small one, 76, divided by 2. Okay, that's the rule. So we'll go 178 minus 76, 102, 102 divided by 2, x equals 51. And that's it. Okay? Just remember, if it's inside and it's not the center, because if it was the center, we could figure out a lot of that pretty fast. Because central angles are pretty easy, okay? But this is not a central angle. When they're outside, then it's a subtraction. So the big one, subtract the small one. When it's inside, okay, inside the circle where the two lines cross, it's a matter of adding the two arcs that are vertical from it and then dividing by 2, okay? Let's try it again here. All right, this one's a little bit different. Right now, what they've given us is an angle here that is not vertical from the two arcs. So we're gonna have to find this one first, or this one. It wouldn't matter which, because all the way around that is 360 right in here on the angles, and we have half of it right here, which is 180. So I'm gonna go 180 minus 102. I'm gonna get 78. So 78 is my angle right there. Okay, if that's that angle, now it's vertical from there, okay? We know that we add these two together, divide by 2, and that equals our angle. So 78 equals, parentheses, 95 plus y divided by 2. Okay, well, we've set it up now. Now we've got to know how to actually solve it. You can't do anything until you get rid of that 2. So we're going to times by 2, times by 2. So 78 times 2 is 156 equals 95 plus y. And now we'll minus 95. So minus 95 and we get 61. That one can be a little bit tricky, you guys. That one can be a little bit tricky. You just have to make sure that you understand that the angles, when the two lines cross inside the shape, inside the circle, you must have them be vertical if we're going to add the things together. Okay, so 102 helped us find the 78, and then we used the 78, the 95, and the y. Just remember, it's the arcs added together divided by 2 equals the angle. Okay? All right, here we have the two intersecting lines outside. So we've got two secants. That's a secant, that's a secant. They're connecting outside. So we've got the big arc and the little arc. That's subtraction. So the formula is 30 equals, so the angle equals A, I'll write that A a little bit better, A minus 44 divided by 2. And I like to put parentheses around that because that tells me I can't touch it until the parentheses are gone. Well, the parentheses can't be gone until I get rid of the 2. Well, why is the 2 there? Well, that's division, so we'll multiply. And that's 60 equals A minus 44. Notice the parentheses went away because the divide line's gone, and we'll add 44 to it. So it should be 104. A equals 104. And you can double check it, you guys. You can double check it by doing this. Take 104, subtract 44, and divide it by 2, and you better get 30. Okay? So those are some examples for you right there. All right? Got a few more to go. All right. Here is a circumscribed angle. A circumscribed angle is when you have basically two tangents that meet outside the circle. We've talked about this before. If I have two tangents that meet outside the circle, it will be a circumscribed angle. Okay? Well, a circumscribed angle theorem is this. The opposite angles, because this is going to be angle ADB, so this angle out here, will equal 180 minus measure of angle ACB. So watch. As long as the two tangents can have two lines drawn to them that are 90 degrees, remember those will always be 90 when you draw them from the center. Okay, they'll always be 90. Then this right here and this angle, so this angle and this angle will always add up to 180. They'll always do it. They'll always add up to 180. So we've got to sometimes use some of our knowledge of previous lessons to help us on some of this. Okay? So basically, hey, it's a four-sided shape, but it's outside the circle. It's not inside. But for this instance, two tangents, so those are radii, and these two angles always will have to add up to 180 because what is 90 and 90? That's 180 on the other side, and it's a four-sided shape. Every four-sided shape has 360. Okay? All right, so let's see what we've got. Well, they want us to find angle X. Well, X will equal 180 minus 35, 135. Should be 45. Got it? Now this one's a little bit different, you guys. We're going to have to do a little bit of thinking here, so pay attention. We're going to do this first. Now, if I do that, I will automatically get 90 and 90. Automatically, because these two lines are tangents. So let's go find angle G here first, where the green lines are created, the central angle. So that'll be 150. 180 minus 30, 150. So now I have this. Okay? Well, you guys, then this arc has to be 150. This arc from here to here has to be 150. Well, look at this inscribed angle. It's an inscribed angle that makes 150, so we know that that's half of it. So 150 cut in half is 75. X equals 75. I hope that made sense. We're going to do one more of those, so that'll help you. Okay? Before we do that one, we're going to do a problem that involves a little bit of trig. So remember trig that we've done in the past. Okay. The northern lights are brightest and flash colored light between 50 and 200 miles above the earth. Okay, those are the things that happen up near Alaska. Okay, a flash occurs 150 miles above the Earth at point C. So it's 150 miles up. It says, what is the measure of arc B to D? So they want us to find that arc from there to there. The portion of the Earth from which the flash is visible. All right. So the Earth's radius is approximately 4,000. So we've got this. Now, if that's true, then we have a 90-degree angle right there, you guys. Well, we have a right triangle trig we can actually do, because watch, I'm going to draw in the 90. Okay, now this is D, this is C, and this is A. So this is the center, and it wouldn't matter. Just make sure your 90 is in the right spot. Now let's go D to A, it's 4,000. Let's go A to C, which is the hypotenuse, that's 4,150. And now let's go find the measure of angle DAC. So watch, DAC. So we're going to find this angle right here. Once I have that angle right there, then I'll be able to find that angle. Once I have both those angles, because they're going to be cut in half. Once I have those angles, then I'll have the arc. Okay? Well, we've got trig. Remember, it only matters what angle you're going from or trying to find. So we're trying to find that one. We have adjacent and we have hypotenuse. That is cosine. So we will say cos x equals 4,000 over 4,150. Now remember, x will equal cos -1 because we're finding an angle of 4,000 over 4,150. So second, you have to hit second to get it. 4,000 divide 4,150, and the angle is roughly 15.5 degrees. So, and always make sure that you were in degree mode. I was. So 15.5 degrees is this little angle right here. 15.5. So this one's got to be 15.5. And if those two are 15.5 apiece, we'll add them up. 15.5 times 2 is going to be 31. So this angle right here, and I'll draw it in green so you can see it pretty good, is 31 degrees. So this arc will be 31. Okay? 31 as far as miles are concerned. So we've got a distance, so you can probably see it 31 miles apart. So 31 is the arc of A to B, or sorry, B to D. Okay? Because that's a central angle, and a central angle is always going to be the exact same as the arc it creates. Okay? All right, this is kind of our last one. It's just a review over what we've done. We've got two tangents, and we know that those angles then have to be 180, so x will equal 180 minus 120. So x has to be 60. And on this one, remember, okay, that's not going from the center, so we would have to make our own center, or our own right triangles, basically. Going over to these, and we know that now we can find this angle, which is 130. And if that's 130, then this arc is 130, and then this angle is inscribed. That's last time's lesson. So it'll be x equals 130 divided by 2, because it's an inscribed angle. So 130 divided by 2 is 65. Okay, and that's it. Like I say, I hope that helps you a little bit. Just remember some of the simple rules that we went through. And are the angles inside? Are they outside? And what arcs does it create? Okay? Just remember, if the point is, let me go back to a couple right here. This one right here is the most important. Okay? If it's a point inside and it's not on the center, if it's a point where the two lines cross and it's not on the center, then you have to take the vertical ones added together, divide by 2. Okay, vertical from the angle, so angle 1. This, I wish they wouldn't put that one there because it's really just 1 with this arc and this arc added together, divide by 2. Now, with these ones on below it, the ones that we were just kind of discussing a second ago, you need to make sure you understand that if it's outside the circle, okay, if it's outside the circle, and it could be a tangent and a secant, could be 2 tangents, could be 2 secants, it doesn't matter. It's the big arc, subtract the little arc, divided by 2. The big arc minus the little arc, divided by 2. And then obviously this one where they are creating 90s because a tangent and a radius always make a 90, which gets us to this problem right here. These two will always just add up to 180. Okay, on this type of problem, you've got to draw it in to find your angle in the center first, and then that'll be the arc, and then cut it in half. Okay, good luck with that. We'll see you next time. We're getting through this. Shake and bake. Bye.